David, there seems to be a fad in physics today that information is the most fundamental thing in the universe. It's not just that information describes matter and energy and fields, but at the bottom of matter is information. Information is the most fundamental. And as a consequence, the universe itself is not a metaphor like a computer, but in fact is a computer, and that's what reality is.
Yes, I'm opposed to that view. I think it misses the point, it misses the lesson of what is really important about the link between computation and physics. Computation, and with it information, is indeed very fundamental, but it's not the most important thing. It's not the thing that the universe is made of, as it were. So there are variants of this theory, like the universe is a computer, or that the universe is a program running in God's computer, or something like that. It seems to me that those theories all miss the point about the universality of computation, which is the way that computation links with physics. Through the existence of a universal computer, a computer that can compute anything that can be computed and can therefore simulate any physical object. If this computer were outside the universe, it wouldn't be very remarkable. You can always imagine some kind of computer with some kind of way of operating that would simulate any laws of physics, no matter what they were. And so you lose the fact that our actual laws of physics are intimately connected with computation. What is the connection? It's not that there's a computer outside the universe, it's that we can make universal computers inside the universe. That is a token of the computability of the laws of nature. It's the reason for the unreasonable effectiveness of mathematics in the natural sciences. It's the reason for the existence of life and the possibility of science. Those things are explained by the existence of computers in the universe, but wouldn't be explained if the universe was in a computer.
If that is true, how do you account for this growing sense that at the bottom, the bedrock of reality is information, that stuff comes from information?
It's perhaps a natural mistake to make, given the fundamentalness of computation. But I think that and perhaps it's the reason for the mistake, now that I come to think of it, is that we are accustomed to explaining things in reductionist terms. Mm-hmm. So instead of the new idea is, instead of explaining things in terms of space, time, atoms, and forces, we explain it in terms of qubits or bits or qubits and computations. But that is not an advance in explanation for the reason that I just said. And the real connection is the computability of the laws from within the universe.
And so that makes information part of the process of the universe, but not sitting at the fundamental nature of the universe.
Well, its existence is indeed fundamental, but it's not fundamental in the reductionist sense. It's fundamental in the sense that there is a law of nature that the universe is computable, or that a universal computer exists.
And would this computation, this information, work on various levels in a hierarchical sense, or would it only exist on the most fundamental level, as you understand information?
Yes, well, computers are emergent objects. There is no such thing as a computer at the subatomic level. Or if you did make a computer at the subatomic level, it wouldn't be universal and therefore wouldn't be fundamental. Mm-hmm. The fundamental computers are the ones that are universal, and they are the ones that are quite big. They're like the computers that we actually have and use in everyday life.
But information could operate on the most fundamental level.
It could and does, but that, as I have argued, can't underlie. That's just an alternative way of talking about atoms.
Okay, but this concept of information, even if it's not at the most fundamental level, when it exists as you see it, does it exist at each level of the hierarchy of the laws of nature? or is it only existing at the level of physics?
Yes, good question. Information exists at every level, including at the fundamental level of atoms. Whether an atom is there or not is a fundamental thing.
Piece of information.
But at the level of laws of nature, information comes in at a particular level of explanation, namely the level at which there are computers and the level at which there are people thinking about stuff. That level of explanation.
How then does that way of thinking allow us to understand reality better?
Because almost all ways that the laws of physics could be do not have the property that a universal computer could exist.